Hopefully you remember what a reduced matrix looks like. So let me jot that down just to make sure we remember. So our reduced two-variable augmented matrix always looks like this: 1, 0, 0, 1. Remember, the ones are always in a diagonal and the zeros fill up every other spot. Okay. So we're going to be looking at some more of these today, but you do need to remember the method that I taught you last time, which was fix the ones first in any particular column and then work on the zeros. Okay, so that's the gist of the rules. If you want to remember step by step, that's fine, but that's really the gist of what we're doing. So let's practice with another one. You know, it is more challenging for you to have to set up your own matrix. In other words, I think it is easier if I tell you what row operations need to be performed and you just perform them than it is for you to come up with your own row operations, which is what you're going to be able to need to be able to transition to. All right, so first of all, don't lose sight of what we're trying to find in general here, right? These are two linear equations, and what are we looking for in general? The point that what? That they intersect, or the point that they have in common, right? That's what we're looking for. We're looking for an x comma y that works for both equations, okay? So the first thing is, if we're going to use a matrix to solve, we need to set up a matrix. So it's going to look like 2, 5, negative 8 for the first row, and then 1, 1, 1 for the second row. Since the understood coefficient in front of an x or a y, if there's not one, is 1, okay? Okay, so hopefully you remember kind of what order, but remember, we want to start with this location, and we really would like a 1 here. Okay, now last time we talked about we could multiply by the reciprocal, but I actually think there's an easier way to get the 1 where we want. Do you remember a row operation that's really easy to do that would get us the 1 really pretty quickly? Yeah, we can do a row swap, right? If we do a row swap, then it will get us the 1 in the location that we would like it. Okay, notice row swaps don't change anything, right? They just change the order of the rows. They don't change the actual numbers in the row. Okay, so notice that operation got us the 1 where we want it. Okay, so what's the next spot we work on? Or the next number we need to change, rather? We want this 2 to be a what? Yeah, we want this to be a 0. Okay, so we only did really, I think, one full-blown example last time. So how could I make a 2 a 0? What could I add to 2 that would make it a 0? A negative 2, right? But I can't just add a number. I have to add a multiple of another row. But notice, since row 1 is a 1, I can multiply negative 2 times that 1, and it still is a negative 2. So I want to do negative 2 times row 1 plus row 2. And this textbook, remember, has an arrow pointing to whatever row is changing. Okay? So in words, what's that instruction asking us to do? Multiply row 1 by what? Negative 2, add it to row 2, right? And then that will be the new row 2, right? Which means, which row's not changing at all then? Row 1's not changing. So we pull that over. And then we just start performing the calculation, right? Negative 2 times 1 plus 2. Negative 2 plus 2 is 0, which is exactly what we wanted to happen, right? But then we have to make sure we do the rule throughout the rest, right? So negative 2 times 1 plus 5 is going to be negative 2 plus 5, or 3. And then negative 2 times 1 plus negative 8, so it's going to be negative 2 plus negative 8, which is negative 10. Okay, so notice column number 1 now, not row, but column number 1 is complete. Okay, so now what do we move on to? Column number 2. Okay, so what do we try to get in place first in any column? We don't mess with the zeros first. What do we mess with first? The 1s first, right? So we really would like a 1 where? In the bottom right? We want a 1 right here. Okay, so let's talk about it. Why would a row swap be a bad idea right now? Yeah, if you row swap, you're going to get what you want here, but what are you going to mess up that you just spent time to fix? You're going to mess up the first column, right? So you never do a row swap once you've already gotten a column established, okay? You don't want to mess up the work that you've already done, then you're just kind of spinning in circles, right? So what's the other way that we get a 1 since a row swap's not really what we want to do? You can always multiply the row by any number you want, right? So what could I multiply 3 by that would definitely make it a 1? I don't use the negative version, right? I use the reciprocal, right? So if I multiply 3 by a third, that'll get me there, right? But remember, I can't just multiply one number by a third. I have to do the whole row. So once again, what row is staying the same then? Row 1. Okay, so we might not love the fact that we're going to get a fraction here, but don't overthink this. Multiplying by a third is the same as dividing by 3. Okay, and that's probably easier to think about in our heads, right? So what's 0 divided by 3? 0. What's 3 divided by 3? 1. And then negative 10 divided by 3 is just going to be a fraction, negative 10 thirds. Okay, so I'm good here, I'm good here, I'm good here. Okay, so what's the final number that needs to be something different? Yeah, this top right one, right? We want this to be a 0. So remember, you get zeros by subtracting or by adding the negative version, right? So how could I get rid of a 1? Add negative 1, right? So essentially, I can just do this. I can just do row 1 minus row 2, because that's the same thing as adding negative 1 times the second row, right? And then I'm going to send that to row what? What row needs to change this time? Yeah, for the first time, row 1 needs to change, right? Because actually, row 2 is done. Why do I say that? Yeah, row 2 is the full-on pattern that I want already, right? Like I actually already know what y is at this stage. Y is going to be what? Negative 10 thirds, okay? So this is not a hard operation to do, so 1 minus 0 is 1. 1 minus 1 is 0, just like we wanted. And then maybe use our calculator to make sure we don't make a mistake, but 1 minus negative 10 thirds would be the same as 1 plus 10 thirds, okay? So that works out to be 13 thirds. Remember, you can use your calculator and the math fraction key if you're uncomfortable with fractions. So the solution then, we may not love it. Okay, we don't usually like fractional answers, but system of equations don't always work out to be pleasant whole number answers. Okay. So just so you know, this is not the only method that you can use to solve these matrices, but the reason I teach it and the reason I like it is because notice that like once we set something or fix it, it doesn't get messed up after that. So if you'll go in this literal systematic order, then you will be ensured that you won't mess something up from a previous step, okay? So in other words, you can do kind of any of the 3-row operations in any order you want, but are you just going to be undoing work that you just did? Okay, this method ensures that you won't do that. Okay. Okay, so let's look at a couple of application questions that we're going to use a matrix to solve, because I do want you to be able to set up some word problems on your own. So I'm going to try to keep these brief. So let's say a farmer plans to plant corn and wheat. He only has 500 acres to plant on. And let's say it costs him $42 an acre for corn. And $30 an acre for wheat. And then let's say that we know that he spent a total of $18,600. So my question is, how many acres of each must have been planted? Okay, so for now we're just solving these two variable systems. Just know that we're actually going to come back to topics like this at the end of the semester. Very frequently in business scenarios, okay, now this is a farm business, right, but very often in business scenarios you have limitations on what you have. In this case, he has limitations on how much money he has, and how much acreage he has, right? So he can't just keep planting forever and ever and ever. He's got limitations to what he can realistically do. So we're going to come up with a system of equations, and instead of x and y, we're going to use letters that make sense for this problem. So I'm going to use C for corn, W for wheat, okay? So on the one hand, he has some restrictions on how much acreage he has, right? Corn plus wheat has to be 500, okay? Or technically less, but we're just going to go for he wants to plant all of his acreage. But then we also have this concept of how much he's spending to do so, right? So how could I talk about how much he's spending for corn? If each acre of corn is $42, how could I talk about that? I could say 42C, right? And then what about wheat? 30, right? And I want to add these together, right? Because he's having to spend the money as a total. And we know that he spent $18,600. Okay, so we're going to set up a matrix to solve. And the reason I'm showing you this is I want you to see that this method works no matter what. Sure, we have bigger numbers here, but the process is going to be exactly the same. We're still looking to get the pattern of, 1, 0, 0, 1. Okay, so where would we generally start? Top left corner, right? What do we want in the top left corner? A 1, and notice we get that for free, right? So we don't have to do that. Okay, it's already a 1. So then we'll move on to what? The 42, right? What do we want the 42 to be? A 0. Okay, so yes, the number is big, but how do I get rid of a 42? Yeah, so I could add a negative 42 or just subtract 42, right? So same. So I'm going to say negative 42 times the first row plus the second row is going to be my new second row. Okay. You also, if you want to, you could say row 2 minus 42 row 1. As long as the negative sign is in front of the 42, then you're good to go. So row 1's not changing. So we get negative 42 plus 42, which is 0, just like I wanted. Negative 42 times 1 is negative 42, plus 30 is going to be negative 12. And then I would probably want to pull out a calculator, but what do I need to do for the last one that I'm not going to try to do in my head? So I need to do negative 42 times what? Times 500 plus what? 18,600. Okay, so I end up getting negative 2,400. Okay, so notice I'm getting slowly but surely I'm getting what I want pattern-wise, right? So now what? What's the next thing I tackle? The one where I want it in the second column, which is where? Right there. Okay, I want the one right here. Okay, so don't overthink it. I know the number's larger than the one that we did before, but if I want that negative 12 to be a 1, I can multiply by its what? Reciprocal, right? So I can multiply by negative 1/12. Okay, remember, it's not negative, the negative reciprocal. It's just the straight up reciprocal. In other words, just flip the fraction. So 12 over 1, or negative 12 over 1 becomes negative 1/12. But it's just like dividing by negative 12. Okay, so what's 0 divided by negative 12? 0. What's negative 12 divided by negative 12? That was my whole point in doing this, is I get a what? 1. And then negative 2,400 divided by negative 12 would be 200. So then very last but not least, I want this to be a what? 0. So I am probably going to do just row 1 minus row 2. So notice row 2 is done. So I actually know how much wheat I already have. And by default, I probably know how much corn too, but we're going to go ahead and write it down and finish out the matrix. So 1 minus 0 is 1. 1 minus 1 is what? 0. And then 500 take away 200 is what? 300. Okay. So notice that for corn, I have 300 acres. And for wheat, I have how much? 200 acres. And notice that together they have how many acres, which was the total amount that we had? 500. And if you were to check the money amount, it would work out too. So again, I think I said this last time, I'm not saying that the matrix is necessarily going to be your go-to method for two variable systems, okay? But just know that the reason I'm introducing this to you is because you might run into some classes where you have much more than two variables, and past three variables, a matrix is the only way to do system of equations, okay? And remember, variables are just unknown quantities, right? So in this case, we had how many unknown quantities? Two, right? But in real life scenarios, there might be more than two unknown quantities, okay? There might be more than three unknown quantities, okay? So in real life scenarios, there might be a lot of things that we're not really sure about that are affecting our profits or our sales or our costs or something like that. Okay, so let's do one more word problem. And then we're going to look at some maybe more unusual matrices. So let's say we have a theater that has child tickets that are sold for 50 cents. And adult tickets are $1.50. I want to know where this theater is because that's real cheap. So let's say that one night all the seats are sold out. And exactly $1,300 in revenue is made. So my question is, how many of each type of ticket? So it's really close to the one that we just did. Okay, it's just instead of corn and wheat, we're talking about child's tickets versus adult tickets. So we still have two kind of equations we can set up, right? We have one that we could set up that talks about the number of seats, and then we have one that we can set up that has to do with the cost of the seats or the money. Okay, so we're going to use C for child, A for adult. Okay, doesn't really matter what order you go in, you just need to stay consistent. Like if you go with C first here, then in the second equation you also have to go with C first. Okay, so if you decided to do A plus C, you would need to swap the second equation also. So what's the second equation going to look like? How much is each child ticket? 0.50, right? Plus 1.50A. And we know that they made how much when they sold out all the tickets? 1,300. Okay, so when I go to set up my matrix, the first row looks fine, but I might not like the second row. How come? Why do you think the second row may not be so pleasant? Got decimals, okay? So this is an optional step that I want to bring up that you can use. So you don't have to. If you're comfortable using decimals and it doesn't bother you that there's decimals there, then you don't have to do this step. But there is something I could do to the second row that would make it more pleasant. Okay? In other words, if I want to get rid of the decimal places, I only want to move the decimal place once to do that, right? If I move the decimal place once, I essentially get rid of my decimals. So what can you multiply something by that gets rid of one decimal place? 10, yes. Okay, so I'm going to multiply row 2 by 10 before I start, because remember, that's one of my 3 row operations, right? So notice I'm not going to change row 1, but I'm multiplying the second row by 10 just so that I can deal with whole numbers. So this will be 5, 15, and then 13,000. Just make sure everything gets multiplied by 10. And then we'll just proceed as we normally would. Okay, so the reason I say this is optional is you can deal with the decimals as they are, and if you're comfortable with that, then just keep going. You don't have to do this optional step. But notice the 1 is in place, right? So I work on what next? The 5. So I want this to be a 0. Okay, so what am I going to need to add to 5 to make it a 0? -5, right? So it's going to be -5 times the first row plus the second row, and that's going to be the new second row. So the first row is not changing. Okay. You can also, remember, write it as row 2 minus 5, row 1 if you want. Okay, so negative 5 plus 5 is 0, just like we want. Negative 5 plus 15 is 10. Negative 5 times 1,000 is negative 5,000, right? Plus 13,000 would be 8,000. Okay, so you can use a calculator if the numbers seem too large. Okay, so now what? Move on to what number? The 10, right? And what do we want in the 10 spot? We want a 1. Okay, so if we use the reciprocal, what are we going to do? We're going to do a 10th times the second row. So always make sure you're doing one of the 3 row operations. Remember, our 3 row operations are row swaps, multiply the row by something, or add a multiple of another row to a row. So divide by 10, you get 0, 1. What about this by 10? Just move the decimal place once, so it would be 800. So I think you can probably predict what the answer will be now that we know there are 800 what? Go back up to the problem. What did we list second in our equation? Adults, right? So we know there are 800 adults, so we probably already know how many children there are, but we're, again, going to finish out the matrix. So if we do row 1 minus row 2, I forgot to say where it was going to. This book actually writes it weird, like in a lot of other books you don't do this thing where you have an arrow telling it where to send it to. But I'm going to model it like I know this book does it. So 1 minus 0 is 1, 1 take away 1 is 0, and then 1,000 take away 800 is 200. Okay, so in the end it looks like on that night there were 200 children and 800 adults. Okay, remember, you can always check your work, right? So not only is it supposed to work for the 1,000 seats, right? Remember, it's also supposed to work for the money when you plug it back in. Okay, so I want to kind of transition to doing 3 variables or maybe something a little more unusual. So we're going to talk about how to do 3 variable systems, but let's talk about what we would be looking for. So let's say I give you this reduced matrix. Notice that, what about the ones? They're all lined up in a what? In a diagonal, and then what's located in every other spot? Zeros, okay? So notice this is my x, right? So this gives me x equals -2. This gives me y equals what? 3, and this gives me z equals 4, okay? So the solution then, remember, is written as a 3-part. Okay, it's actually called, whereas these numbers are called ordered pairs, these are called ordered triples. Okay, so before we transition to 3 variable systems, just to make sure that we know how to read something when it's already been reduced. So I want to talk about unusual solutions. Okay, kind of special cases. So the first special case is you're doing your method for matrices and you're pretty sure you're doing it right. But you end up with the last row looking like 0, 0, 4. So before we try to make this matrix be what we want, let's just talk about what we have here. What does the first row mean? 2x plus 3y equals what? 5. And then the second row looks like 0x plus 0y equals 4. Okay? And notice I put a question mark there because why? That's not possible, right? What is 0 times something plus 0 times something else going to have to be? It's going to have to be 0, right? So because we get something that's not possible, we don't need to adjust and move this around. This is never going to be what we want it to be. It's never going to be fully reduced. And this is what a no solution system looks like. So if you're solving and you end up with one row that looks janky, okay, then it's a no solution. Okay, you don't even need to bother with the other rows. One row, it's kind of like, one bad apple spoils the whole bunch kind of thing. Okay, one bad row messes the whole thing up. Okay, so the first type of unusual solution is a no solution. So a no solution occurs when you get zeros on the left in a row and something else on the right. In other words, something other than 0. Okay, so it doesn't matter what it is. In our case, it was a 4, but it could be any other number. So I want to contrast that with a second unusual solution. So let's say that I end up with this as I'm working through my matrix. So rather than a 0, 0, and another number, I get 0, 0, 0. Okay, so let's talk about what that would mean, right? The first row would read x plus 3y equals 4. The second row would read 0x plus 0y equals 0, which is actually true, right? It's actually always true. So rather than being something that kicks the answer out, notice that it doesn't really matter what x and y are, right? 0 plus 0 equals 0 will always work. So in this case, there's actually infinitely many solutions. And I'm going to say more than that. It's not just infinitely many solutions, it's actually any point on that first line, x plus 3y equals 4. In other words, the final row doesn't kick us out. The final row just frankly doesn't tell us anything. Okay? So before I describe that, what I mean by infinitely many solutions is I'll give you one example of a point that would work. 1, 1 would work. Why? Like, look at the equation and tell me why 1, 1 would work. Because 1 plus 3 times 1 is what? 4, right? But 4, 0 also works, right? Because why? 4 plus 3 times 0 is also 4, right? So you can come up with multiple answers, in fact, infinitely many of them. Okay. So just so you know, I'm going to draw a picture here. A no solution looks like this. Okay, notice they have no points in common. So let's talk about what infinitely many solutions looks like. So infinitely many solutions looks like a row of all zeros. And no clear solution. So I'm going to say no clear single solution. Okay, because there are solutions, there are just infinitely many of them. So you might think, like, how is that possible? Because how do I make a line cross each other at more than one spot? Well, it's when you have a line and then the other line happens to be the same exact one. And so it lies right on top of the line that you had before. And if I had to ask you how many times these two lines intersect, what would you have to tell me? Infinitely many, right? Like they touch each other everywhere. Okay, so in other words, it's every single point on this line because they're crossing each other always. Okay. So just know both of these things are unusual. Okay. No solution means no matter what we try, nothing's going to work. Infinitely many solutions doesn't mean every point works, right? It just means every point on this line works. Okay. So there's infinitely many ordered pairs that would work out. Okay. So let's go ahead and keep that in mind. Let's look at solving 3 variable systems now. Now, if you followed along with the 2 variable system method, I think the 3 variable method will make sense to you. And I think someone even asked about it last time, if I remember right. So the method is logically the same, okay? We're going to start with column 1. Okay, so tell me what I want the first column to look like when we're talking about 3 variables. What do you want that very first column to look like? Yeah, you want a 1 on top and 2 zeros below it, right? That's what you want. Okay, so just like with the 2 variable systems, we're going to get the 1 in place first. Okay, remember how we did that. We either do that with a row swap occasionally, or most often we're going to multiply by the what? By the reciprocal? Okay, and then the second thing is we're going to get the zeros in place after that. And remember how we do that? We use the opposite sign. So if it's a 3 we want to change to a 0, we use a -3. If it's a -2 we want to make a 0, we use +2. So step number 2 is once column 1 looks good, you're going to move on to what? Column 2, okay? So you're going to repeat steps A and B for column 2, but what you're going for with column 2 is a little different, right? So what do you want column 2 to look like? 0, 1, 0, good. So then I think you can guess the third step, but what's going to be the third step? Now that you fix columns 1 and 2, you need to fix column what? 3, and then you'll be good to go. So these are longer just because you have more numbers to fix, more columns to fix. But process-wise, it's not really any more challenging. Okay, what do I want the third column to look like? 0, 0, 1. And then 4 is just to write your solution, because once you have a reduced matrix, you've got your solution right there. Okay, so these are going to take us a minute, okay? They're not going to be just super fast problems. So let's work through one together, and that's honestly probably all we'll have time for today. But let's see if we can fix or finish this one all the way through. So I'm going to have 3 variables and 3 equations. So x plus y plus z equals 4. 2x minus 3y plus z equals 1, and negative x plus 4y plus z equals 5. So my first step is to write the matrix. My strong suggestion to you when you do this on your own is before you start the kind of lengthy process of solving these, do a quick check and make sure you wrote down all the numbers right. It really sucks to spend 10 minutes on a problem and realize you wrote, a 2 when it was supposed to be a -2 or something. Okay, so always check back and make sure you have all the numbers right before you work on starting. Okay, so we're going to do this in an organized fashion, right? We're going to go for the first column, fix it, go for the second column, fix that, and then finally go for the third column. So what do you notice about the first column, though? We get something for free. The 1's already good, right? But I need to make these what? I want to make both of those zeros. Okay, so we can do that in one step. We just have to have like 2 parts to the step. So let's take them one number at a time. So what do I need to add to the 2? -2. So I'm going to go -2 row 1 plus row 2, and I'm going to send that to row 2. Okay, and then in the same set of instructions, I'm going to get rid of that one, right? I'm going to change that to 0. So what would make -1 a 0? 1, right? So that's a little bit easier. I just need to take row 1 plus row 3, and I'm going to send that to row 3. Okay, so which row's not changing? Row 1's not changing, so we'll pull that over. So it doesn't matter what order you do these in, and I usually like to tackle the easy one first. Okay, so the second instruction looks easier to me, right? I'm just adding rows 1 and 3, and I think that's going to be quick, right? So what's 1 plus -1? So I'm adding these two, these two, these two, these two, right? So 1 and -1 is what? 0. 1 and 4 is 5. 1 plus 1 is 2. And then -4 plus 5 is 1. Okay, make sure you put it in the third spot, right? Because this instruction's replacing row 3. So now let's go to this one. It's a little harder, but not too bad. Okay, so we just need to do -2 plus 2, which is 0. No shocker, right? That's what I wanted to happen. That's actually why I chose that set of instructions, right? -2 plus -3 would be what? -5. -2 times 1 plus 1, so that'd be -2 plus 1 or -1. And then be careful about your signs. -2 times this plus this, right? So what's -2 times -4? 8 plus 1 is 9. Okay. So if you need to, you can use a calculator if you need to do the individual steps. Okay. Okay. Don't hate me here. Because this problem is going to not work out pleasant, so I need to pay attention to my own advice, except I actually just changed the problem. We're going to change this to a +4, because if we don't, it's going to be ugly. So the only thing that is going to change is actually both of these. Okay, so erase that real quick. All I did was change this to a 4, that to a 4, but it's going to affect the calculations that involve that number. Okay, so let's go back and do this one. 4 plus 5 is 9. And then -2 times 4 is -8, plus 1 is actually going to be a -7. It's not that it wouldn't work like that, it's just that I picked a problem that came out nicely, and that was not going to come out nicely. And that's not really my intention on your very first one, to make it super, super ugly. Okay, so notice all of these are good, right? So the whole first column is good to go. Okay, so I move on to what? The second column, right? So specifically which number? The 1, the -5, or the 5? What needs to be the very next thing we tackle? The -5, and we want this, I'm going to do this right here, we want this to be a what? We want this to be a 1. Okay, so temporarily we might find we get a little uglier answers than we would love here. Okay, so remember, we use the reciprocal to get the 1, right? So we're going to do -1/5 times row 2. Okay, but notice a lot of this step is just pulling over what's not changing, right? Row 1 isn't changing. What else isn't changing? Row 3 isn't changing either. So I'm just pulling those over. And then just remember, it's just like you're dividing by -5. Okay, so 0 divided by -5 is 0. -5 divided by -5 is 1, just like I wanted. -1 over -5 is going to be 1/5. So this is where you're going to have to be okay with maybe some ugliness in between. And then -7 divided by -5 would be +7/5. Okay, so we're good, good, good. Good there too, right? So what's next? Yeah, I want these to be what? Zeros? Okay, so let's think about it. So what's going to change row 1? What am I going to need to do there? Yeah, I'm going to need to add a negative or subtract, either one. Okay, so I'm going to do row 1 minus row 2, and I'm going to send that to what? To row 1. Okay, because row 1 is what I want to change there. What about this? What can I add to a 5 that would make it a 0? -5, right? So I'm going to go -5 times row. You can use row 2 or row 1, but I'm going to use row 2. Row 2 plus row 3, and we're going to send that to row 3. So what row's not changing because I didn't put an arrow to it? Unfortunately, row 2 is the one not changing, right? I say unfortunately because it's the one that has the ugly fractions. So we're just going to use our calculator when we think we need to here. So 1 minus 0, we don't need it for that, right? That's 1. 1 minus 1 is 0. But maybe for the 1 minus a fifth, maybe not. Okay, think of 5/5 minus 1/5, or use your calculator, but you're going to get 4/5 here. But I would say certainly for the last one, you'd probably pull out your calculator. So 4 minus 7/5 is what I have in that spot, right? So let me move that up, sorry. And then when I get this, just go to math fraction. And notice it's 13/5. Okay, so we'll keep the calculator out in case we think we need it. -5 times row 2 plus row 3, right? So 0 and 0 is going to stay 0. -5 plus 5 is going to be 0, just like I want. And then now let's use the calculator, right? So it's -5 times what? 1/5, which that's actually going to be nice. And then I need to add what? 2, which is the 1 in row 3, right? So notice I just get 1 there. And then we'll do it again here. -5 times what for the last pair? 7/5. And then plus what? Plus 9. So notice we get 2. So we're almost there. Okay, so I'm going to do some check marks just because it gives you a little bit of satisfaction, right? Those are good. And now I'm going to move on to the third column, right? But actually, this is good too, right? Like the 1's already where it's supposed to be. So we actually only have one step left, right? What do we want both of these guys to be? We want them to be 0s. Okay, so I'm going to finish this up real quick. Okay, remember, we get 0s by adding the opposite sign. So it's going to be -4/5 row 3 plus row 1. Because -4/5 plus 4/5 would be 0, right, which is what I want. And then I'd use -1/5 row 3 plus row 2. And I'm going to send that to row 2. Because row 3 is actually finished. Row 3 is equal to what? Like z is equal to 2, right? Like we already have it. All right, so I'm just going to do it real quick because it actually works out pleasantly. You're going to find your answer comes out pleasant in the end. So we're going to have 0 plus a 1, which is still a 1. You can kind of assume that nothing that you already did is going to get messed up. 0 plus 0 is still 0. -4/5 plus 4/5 is 0. But then let's pause and make sure we do this next one right. Okay, so what do we need to do? So -4/5 times what? Times the 1, right? Is that where I'm at? No, times the 2. And then plus row 1, which is 13/5. So yes, it was ugly in the beginning and throughout the middle, but it came out to be nice in the end. And then lastly, here we're going to get 0, 1, 0, because that's the way we've set it up. Okay, so I'm kind of going quicker through it just because we're kind of out of time. And then here we need to be careful, right? So it's -1/5 times 2 plus 7/5. And notice even this one comes out to be pleasant as well. So kind of labor pains there, right? But we get a nice, pretty baby in the end. Okay, so the solution is just 1, 1, 2. Okay, so I'm not promising that you'll always get pleasant answers, but a lot of times your work in the middle may be ugly and your final answer will be pleasant. Okay, so we're going to do some more of these on Monday, but just remember your strategy is to fix column 1, then what? Column 2, and then column 3, and within that, what comes first, 1s or 0s? Always 1s, okay?